service of the system. Click on the server instance and select the property. You change it to
Hello and welcome to Analysis Services, Part 1, the tabular model and why you need it. This will actually be a series of videos I want to do because I think there's a lot to cover and I don't want to just try to cram it all into one little video. And we'll cover a lot, but I want to start with the basics. The most important thing to understand about analysis services today is the tabular model and how to relate that to Power BI and business intelligence in general. And I want to point out that there's Azure Analysis Services and then there's SQL Server Analysis Services. And functionally, they accomplish the same things, and they pretty much are comparable, I guess. The features are pretty much the same across either one. However, ease of use, scale, turnaround time, etc., obviously is a lot better on the cloud service. The cloud service is a PaaS service. And SQL Server on-premise, you'd have to have like licensing and things to use analysis services. It's part of SQL Server. But in Azure, it's actually split out as it's a completely separate service. You don't have to have SQL Server. You don't even need to have anything related to it. So you can really use it as a standalone service. And we'll talk about what it does and why you want it. So the main thing I wanted to point out, though, is the main point of analysis services is to deliver the full business value of intelligence, or a full value of business intelligence. And we'll talk about what that means. Now, sometimes people tell me they get confused between the legacy, and I want to say it's still very relevant and critical and useful in some cases, which is the multidimensional model. But that's the one that's been around for a long time, very established. But the tabular model is really a completely different animal. I'll explain why, and we'll go through some of this. But to really understand the differences, I encourage you to look at my other video. I'll put a link at the end. This is just really an image, but it's called What's the Difference? Analysis Service, what's the difference between the tabular and the multidimensional models? They are significantly different. So we'll take a look at that. Let me go in. This is a book I got. I really liked it, and I recommend it for understanding, especially on-premise, but it really, again, the functionality goes across the board. It's a very comprehensive book covering the tabular model and analysis services. So good job, guys, writing that. So in the beginning, users needed to analyze data. So business intelligence was created. But there were too many requests, and users started doing their own analysis, and the world descended into chaos. And Microsoft said, let there be Power BI and the tabular data model, and all was good. Pretty dramatic, huh? By the way, I am drinking out of my SQL Server coffee mug. Could also be a beer stein, I'm not sure which, but I don't drink a lot of beer, I do more coffee. So what's the goal of business intelligence? I want to start really at the very beginning. It's to leverage an enterprise's data to provide actionable insights to management. And that's really becoming such a catalyst all around the world for organizations. So much data being generated, whether it's a Fitbit you're wearing, or there's IoT stuff, there's cars generating things, there's equipment in a company, but there's also lots of stuff coming from weblogs and traditional data sources like online transaction systems. It's data coming in from everywhere, and it's growing and growing and growing. And just a couple of years ago, I would have said very few companies have big data. I won't say that about almost any company anymore. There's lots of good use cases everywhere for big data. The business intelligence goal from the very early stage was to turn all this data into something management can use to deliver better value, help customers improve profits, decrease costs, really have that better insight. What are our customers doing? What do they need? How do we sell more products? Where should we be selling products? How do we reduce readmissions if you're in a hospital? All these different types of questions and problems. And we're going to talk about what that solution is. So I'm taking the sort of big view of business intelligence. Some people take little view. I take the broad view. So I think predictive modeling, machine learning, big data solutions, I think they can all fall under the business intelligence umbrella. But what often happens is business intelligence teams get so inundated with other things, they have a hard time getting out from under it to be able to focus on the really higher value items that they were originally established to deal with. So where are we heading? We're going to talk about what is the tabular data model. Then we'll look at why analysis services and what is it offering. What is analysis services? The features and benefits. And kind of throughout this, we'll get a look at the tools involved in doing analysis services. I want to call your attention to the link at the bottom here. I have a GitHub account. If you've watched my other videos, you'll know that. github.com/bkafke/shared. And you'll find this under analysis services, and I'll stop breaking out different presentation slides that go to part 1, part 2, part 3. Hopefully this will get as in-depth as I can get with it, and you'll get a lot of value. So let's start with what is the tabular model. I'm going to go through some attributes to help clarify what the tabular model really is. First and foremost, it is an in-memory table. Now, I want you to sit back and really draw that in, because sometimes, regardless you say that, people don't quite get what that means. It's actually taking that data and it's pinning it into memory. All right, it's actually staying in memory. It doesn't go away. SQL Server, you run a query, it pulls the data off of disk, does what it wants, does what you ask for, it gives it to you, and then drops the data out of memory unless there's some reason to keep it in cache or something. That's not how it works in the tabular model. Tabular model, even before you've asked for the data, it's in memory. All right, so in the analysis services at least, it would already be sitting in memory just waiting for you to ask for things, and it stays there. So it's an in-memory table. It's highly compressed. So the first question people have is like, wait a minute, I got a lot of data and I need to query it and stuff, and you're telling me this is all in memory? Well, what if it's, we'll say, a terabyte of data? What if it's a couple of hundred gig of data and stuff? How are you going to be able to satisfy that? That becomes the second question. How do we deal with that? Well, it turns out that Microsoft has a technology called VertiPack, and VertiPack compresses all the data so that it's a lot less. So in analysis services on Azure, you can actually have a compressed model up to 400 gigabytes, which can be a number of terabytes depending on how the data is and how it can compress it. So you can see that you really can handle large data sets. And most problems that people want to query and analyze really fall into that. Usually you look at sales maybe up to 3 years back. When you're looking at 10 years worth of sales, you're looking at something very different. Usually you're kind of doing year-over-year analysis. So it really works. Rows are stored at the lowest level of detail. So you're not trying to aggregate ahead of time. If you think of the old dimensional modeling, warehouse, this kind of thing, you tend to aggregate and you say, what's the grain level with the Kimball method? Here you get the lowest level of detail possible, and then you slice and dice and query. Again, since it's highly compressed and since it's in memory, and it uses a technology called column store, so instead of doing these sort of row type of indexing that SQL Server would typically do, it's doing a column orientation, and it's lightning fast. So we can actually summarize instantly anything you ask. Summarize by department, summarize by code. Slice and dice this way, it does it quickly. That's the beauty of the tabular model, especially when it's using analysis services. Within the Power BI environment, we have the tabular model, we'll talk about that. And the tabular model also includes the rules on how to import and structure the data. So it's kind of a weird thing. If you think of like in traditional, say, Sql Server Database, you have your Sql Server Database, then you have ETL, this is a warehouse, we'll say. We have ETL and you write SSIS and it pulls in all these things and it loads the data warehouse. But imagine if you put the two together, and that's the tabular model. So you actually define the ETL rules, the transformations, the calculations, etc. And then you tell it how to join it. And then it actually will materialize that and turns it into a tabular model, and it will install it as a tabular model database, and it will pin it into memory, and it's good. So it's kind of an all-in-one kind of packaging, and it's much, much easier to use. It's a lot easier than doing like SSS with ETL type stuff. It's designed to be used by end users. And believe it or not, as easy as it is for end users to create these models, it's just as easy for business intelligence people to do it. But don't tell your customers that. Make sure they think it's a lot harder, so they give you more money, more pay, and you can kind of tell them how hard your job is. But we know better. All right, includes calculations, measures, and more. So one of the things in the tabular model is that you can create calculated columns. You do measures, which are basically aggregations of sales amounts and things. You might want to do averages. You might want to do first and last, the highest, lowest type stuff. Or you may just want to tally things up, and that's what the measures do. And there's lots of other things like KPIs, etc. And I like to think of it like the way I kind of frame this. If you come from a SQL background, this will make sense. If it doesn't, don't worry about it. We'll go into more things. But in SQL, I write a query and I can say, I want to pull data out of the sales table. And oh yeah, the sales have a product code. So I'm going to take the product ID and tie it back to the product table, join it, and I'll pull out the product name and category or something. And okay, great. I run the query, I get it, and say, you know what? I use this so often. I'm going to create it as a view. And what a view does is it lets me use that query as if it were a table. So all that joining, and if I've added calculated columns in that view, it's automatic. And so it treats a view just like a table. Now, if you take that idea of a view, but instead of giving you the results of the view and then dropping out, it just holds that view in memory, all the results for everything ever, sitting there in memory, that's, I think, a good way to picture, at least, the tabular model. Some people may tell me that's not exactly how it works. I'm pretty sure it's not, but it does give me a good framework for like how to think of it. It's in memory. I can slice and dice with it. I will put the caveat around this that with SQL Server, obviously, typically you're pulling in queries. You're going to be pulling in all SQL tables. But with the tabular model, it could be pulling in CSV files. It could be pulling in, Spark stuff. It could be pulling Hadoop or anything you can think of. It could be going out to Salesforce or Dynamics or something, bringing data in. So there's a lot more richness to it. And that's where, it actually does really a lot of this sort of ETL work for you. And it would be a lot harder to do that in SSIS. So but it's still doing very similar types of functionality. All right. Bottom line is, the tabular model is designed to create the data in a format that's consumable. It's ready to eat. It's like the TV dinners. You say just heat and serve and you're good to go. That's what the tabular model is designed to do. Once you've created, you have to do that as a first step in every Power BI project. Where's my data? How am I going to use it? Then I can consume it in my visualizations. So that's kind of a key factor. So let's step back, and I want to do a little Power BI demo to kind of give you a sense of how this looks and how it works. So I'm going to go over here, start my Power BI. And if you haven't seen Power BI, get it. It's awesome. I have a link actually right there. Go back to it. But if you get the slides on GitHub, you can download Power BI Desktop for free. Honestly, it's free. What can I say? I'm not selling you anything here. You go out, you download it, it's free. Everything I'm going to show you is available. It's got a lot of power, and you can do a ton of stuff and never pay a cent. And so, how does Microsoft do that? I don't know. There are a lot of value-added services, and I think that's probably, what you might want to look at. But you don't have to. You can do a lot just with the service as it is. So the first thing, when you go to Power BI, I'm going to say Get Data. Now, one of the things you're going to notice about Get Data is that you have a lot of different types of sources. I honestly cannot think of, unless you have some really odd proprietary source, it's here. It's Oracle, it's Teradata, it's SAP, it's whatever you want to get. And you can also do different files. So I'm going to do database. I'm going to do a SQL Server Database because I already have them loaded. It's all set to go. And I'm going to use good old localhost. And the database, I'm actually going to say import. I'm not even going to pick a database yet. I do want to call your attention to import versus direct query. Most of the time, I would argue you should be looking at using import. So import's going to ingest this data, as I mentioned, ETL. It's going to use like an ETL engine that's behind the covers you don't see, suck in all this data, put it in place, format it the way you want, and you just query off that. So as I mentioned, pins it in memory, and you just slice and dice off of that. The beauty of that is it's very fast, and you're not putting additional strain on other resources. If you were to do something like direct query and then pass it through to, say, a SQL Server Database, now you're sending off SQL statements for every different summarization, slicing, dicing, and you're putting a lot of load on that SQL Server Database. Generally, a SQL Server Database, I don't think would be a place you want to do direct query unless you have very unique situations. The more probably appropriate places for direct query is something like you're using Hadoop or Spark on the back end. Massive amounts of data, you're talking petabytes. It's not feasible to fit that into memory. And so in a case like that, you may want to say, I'm just going to pass the queries through to an engine which is really designed to answer those things fast. My guess in some of those cases, though, it's still hard to get that quick slicing and dicing. So you have to look at that carefully. Whenever possible, I think it's better to try to use the import method. But as I mentioned, there are use cases, and especially when you get into big data backends, where you may not be able to do that. So in our case, we don't have that problem because we're using AdventureWorks, and I know it fits. So we're going to use import. I'm going to say, OK. I did not give it a database name, so it should prompt me. And it does. And I'm going to say AdventureWorks Data Warehouse. So here it is. And I can select what I want to pull in for tables. So I'm going to go in here, and I'm going to say, yeah, I'm going to pull in, we'll say, geography. Check it off, and you can see a preview. I'm going to pull in sales territory because that connects me back to my geography. And I'll pull in internet sales, right? Somewhere in here I have internet sales right here. Once I'm done, I just say load. And as I mentioned, you're going to see it go through its gyrations. It's going to start loading. You can see it here, loading the data. So it's ingesting all this data. And I can drink another sip while it does. And it's pretty fast, but again, if it was massive amounts of data, that would be where analysis services would save you some time. That refresh and that ingestion, if this were analysis services, would happen prior to a user even consuming it, so they wouldn't have to wait at all. But I'm building this in Power BI desktop, the free version, on the fly. First thing you should notice it created the model to a large extent. It gave me a nice jump start. I have this visual environment. Looks a little like Access or Power BI does this, as we see. But we can see that if I highlight this, I can see that the sales territory key maps to the sales territory key, right? And if I want to know what's this relationship doing, it helps if so I'll just go here, and you can see that again, the sales territory key and internet sales. So we've got this connection going between things. So what this really is a join. In fact, internet sales can join to sales territory, can join to dim geography. Now, back up, take away, reverse. Here's a differentiator between the old multidimensional model. Multidimensional models really like to have a dimensionally created model, a Kimball method model under the covers, which is called a star schema. Star schema would have the fact table with the measures, only metrics that you want to summarize and aggregate, and anything that describes that data would hang directly off of it as a dimension table. But here we have what's called a snowflake, which is a dimension which is split off from another dimension. That is a good design in OLTP. It is generally a poor design in data warehouses because it's not good or efficient for reporting and typically creates a lot of awkwardness. However, in the tabular model, this is really going to be sort of sucked into one giant table anyway. So that impact that we would have had perhaps in the old the old cube is not going to be an issue here. There may be some implications, but not really too much. We can just pull it in and join what we want, which means it's also a better tool when you don't have a Kimball method dimensional warehouse, but you've got some extract tables and things and maybe spreadsheets, and you just want to be able to query against it. It's a lot easier to do that with this than the MDX multiple dimensional cubes. Okay, so you get the query. That's great. What about we want to do work on the individual tables? We click on this button. So these two buttons, that is our tabular model builder, editor place within Power BI. And by the way, does that mean analysis services is running as part of Power BI? Yes, it does, but not the full-blown optimized analysis services that we would get on, say, the Azure PaaS service or in SQL Server Dedicated as a server. It's kind of like if you have SQLite, you can think of this as sort of analysis services light sitting on this, and it's all stored within the PBX file, and I'll take a look at that in a minute. But see, we have geography, etc. So let's say, here, I mentioned these little summation signs means that Power BI has figured out that these are numeric columns and probably facts, so it automatically says I'll aggregate those as sums. But I could say, don't do it as a sum, do it as an average, do it as the minimum, maximums, etc. But I'm going to leave those. But what I do want to do is, if I want to modify columns, I can do that, and I can right mouse click here. And you notice I can do things like create a new measure. I can edit a query behind it. I can rename the column. So I can say call it something else. What I want to do here is I'm going to say create a new column. And what you get here is this, what do you want to call the column? It's creating a little formula. All it is a variable name, column name. How do I create it? So I'm going to do something like state sales tax. And I'll say it's equal to. Now, as soon as I use the left bracket, it says, oh, I assume you're bringing in a column, so I can now look for sales amount, which for people like me who are lazy and like to do that. And I'll just say in Massachusetts, it's about 7%, so I'm going to say that. So notice it's just a little calculation. This is called DAX, the Data Analysis Expression Language. We've got to have acronyms, right? So here I can now check it. It says, yep, it's good, and it adds this calculated column. And you can see it here. I can rename it. It's also here, sales tax, etc. And I can create many things. Now, I'm not going to get heavily into this because there's lots of things I can do. The takeaway I want from this demo for you to get is, okay, so I'm building out the underlying data source with whatever I need to do to massage it, clean it, whatever. This is where I'm building it. Lots of rich tools in here. I wish SSS were this easy because it's really nice to be able to do this. But then again, you probably wouldn't make all the money you make if it was that easy to do it, right? But in the tabular model, it is, and this is why you're going to free yourself up as a BI person, because you can do it just as easily when we talk about using Visual Studio to do the same thing. So now that we've got that, we can just go in here and say, okay, I want to do some stuff here. And I'm not a real visualization kind of person, so I'm going to drag this out a bit so I can